Okay, let's get that brain and spinal cord set. So we're going to now see how the brain and the spinal cord form. And what has to happen is that there is a neural tube that stretches from the very back end of the spinal cord down by your tail, if you had a tail, all the way to the very front of the brain. And that comes from the neural tube. And if this is actually where we're going to go. The neural plate is actually going to curl up into a groove, and then it's going to actually bud off. And if we can now go over to the board, what I've drawn here is a cross section through the embryo. So if we took a cross section right here, what we'd see is our neuroectoderm, with the part of the neuroectoderm that's going to become central nervous system, neural tube, and then the part that is going to become neural crest in red. And this starts to invaginate, and you get this kind of a groove. The plate becomes a groove, and then it buds off, and it actually becomes a tube. But that tube actually has to then be covered by ectoderm, so that the central nervous system is below the surface of the body. And so this is ideally what we're going to get, is a neural tube that is surrounded by these neural crest cells that are going to go elsewhere in the body. So the way that this neural tube forms is that it first starts to form about right here at a place that's going to end up being around the neck of the embryo. And from this start of the closure, what we get is a zip up in both directions. And then a little bit later, there's another zip up that starts at the very front end. And everything proceeds until there's a closure up here at something called the anterior neuropore. And then a little bit later, we close down here at what's called the posterior neuropore. So this is happening between days 21 and 28. It starts at 21, it goes really quickly, and before day 28, so in the 4th week of gestation, this neural tube is forming. Now, it is an extremely common thing for there to be a neural tube defect. And the neural tube defects take one of two general forms. One is that the posterior neuropore does not close. And if the posterior neuropore doesn't close, you get something called spina bifida. And this just shows an example of a serious spina bifida, where what you can see is that the spinal cord, which is right here, actually gets externalized out here. Now, first of all, that's a problem because there's really not much protecting the spinal cord. But in addition, as you may imagine, because this is longer, it actually tugs on the brain. And so the brain is pulled back. And so associated with very severe spina bifida can be some brain abnormalities just because the brain is under such a stress. This needs to be corrected surgically. But it is also important to know that there are a large number of people that have spina bifida at a much more mild case of spina bifida. And these individuals don't even know they have spina bifida, and there is no intervention that's needed. Typically, somebody will come in after maybe having some back pain or something, and they're taking a picture of this person's back to make sure that they don't have a slipped disc or something of that sort, and they say, oh, by the way, did you know that you have a mild case of spina bifida? And then and that's how these things come to light. So spina bifida is a very variable severity, from completely without symptoms, asymptomatic, to needing surgery and also causing permanent disability. Okay. The other type of neural tube defect is more severe and is consistently severe, and that is when the anterior neural pore does not close, and that causes something called anencephaly. There's no brain. All right, and this is an individual with anencephaly. It's a neural tube defect of the anterior neural pore. These people, so this group here, this is the pie chart. This is the percentage of people that live for more than 5 days. So it's a very small number, and this is so this is a very devastating disease. Now, the interesting thing, or the important thing about neural tube defects and neural tube closure, is that we can prevent a lot of them, and we prevent them by supplementing diet with folate or folic acid. And because most individuals do not, the vast majority of individuals who are pregnant do not know that they're pregnant at day 21, what Western governments have decided to do, this is true in many countries in Europe, this is true in the Caribbean, and it's true in the United States and Canada, has been to require that grains are supplemented with folate. And so assuming an individual eats grains, eats cereal, eats bread, they will have enough folate, and this can greatly, greatly reduce the chance of getting a neural tube defect. There are two cautionary notes. One is that gluten-free products are not supplemented with folate, so that's something for people that are eating a gluten-free diet to keep in mind. And the second is that it depends on a diet that actually has grains in it. So there are instances, an increasing number of instances in the United States where people's nutritional diet is insufficient to give them enough folate to prevent these neural tube defects. Okay, so now in the next segment, what we're going to do is we're going to see how this neural tube is actually going to produce the spinal cord and the brain.